Hi, welcome to this video. In this video, we are going to be addressing chemistry question, a chemistry question from grade 12, particularly acids, right, and bases, the reactions involved, right? So acid-base reactions. In this case, we're going to consider a question, and the question is as follows. If the acid dissociation constant, and this constant is given by Ka, for an acid, and let's say this acid is some H, right, HA, right, we don't know what this is or has a value. So this dissociation constant has a value of 8 times 10 to the negative 4, and this reaction or this dissociation is happening at 25 degrees Celsius. The question then is, what percent, right, of the acid is dissociated? So dissociated in a particular volume. So in a 0.5 mole per cubic decimeter solution, sol of HA, happening at that same temperature at 25 degrees Celsius. So this is the question. We have to then begin the solution by looking at what happens when you're dealing with an acid. And we know certain things about an acid. So since it's an acid in this case, so let me say answer. It's going to be given here. Let me perhaps use the color blue. So we know that for an acid, we have this particular reaction that happens. That the acid ionizes with water. So HA has to have a reaction with H2O. And this then gives us a result where we have some H3O plus being produced plus A negative. And how does this even happen? By definition, right, an acid ionizes with water, but also an acid is a proton, right? So it gives off a proton. It's a proton donor. So this hydrogen will be given off and be absorbed by the water. So it gives off a plus H, right? And therefore, we are left here in this situation with only a 8 to the negative 1, which we see on the results over there on this side. So, another way that one could even consider this reaction, since we're talking about dissociation, in other words, the acid separating apart, you could even think of it as simply being HA that you had initially. This dissociates into an H plus ion, which is what we see here at the top, right? And then plus some 8 to negative 1. So this is what one could even think of as you are doing this particular question. Then we then see that there is a ratio that exists, but we are first of all told that this reaction or this acid is dissociated from a particular concentration. So we had an initial concentration of HA. So we had here HA being simply 0.5 mole per cubic decimeter, right? But then we have this reaction happening to end up giving us new products. So we could even say that initially we had some amount of volume or some amount of concentration, and this amount is then removed. In other words, a certain percentage from that is being removed, and we can call that percentage X. So we denote to this some concentration, a new concentration called X, and some concentration to this one called X. So because we are producing X, but we are removing this X from what we had initially, we can say from this one we can subtract this same concentration. So a concentration that is then produced, we can subtract it from the previous, from the reactant side. So we actually have that HA is going to be this value, and then this one in terms of its concentration. So we can then say H3O in its concentration is equal to X, And then, of course, your A in terms of its concentration, -1 with the plus on the H3O. That's again equal to H. Okay, but why do we even do this? Well, how does this even help us? This helps us because we have got the acid dissociation constant, and it is given in an equation. And this is Ka is equals to sum H3O plus and sum A to the -1, or negative rather, and all that is then divided by what we had initially on the product side, on the reactant side. So that was our HA, right? Or you can even look at it on the second reaction I wrote, which is then going to be Ka is going to be given by what is the dissociation. So we lost an H plus, then we were left with an A to negative, right? And all that was divided by what we had initially. And what did we have initially? It's only HA. So this is what we then have. But we already said something about what these values are. That H3O is an X, so we can make it an X. That A again is an X. And at the bottom, we know what the value is. We said 0.5 minus X, right? Or you could have been thinking, well, I mean, initially I just had 0.5. Why not just have 0.5 as a result, right? And therefore you'd have X, in fact, this then becomes X squared divided by 0.5, right? Minus X. But then you could have been saying, why would I even make this particular value of X? So on the previous page, we see here, we say that we lost some amount of X, right? You could have decided to just have 0.5 on the left-hand side of the reaction, and on the right-hand side, you just have X and X, right? That can also work. Or you can put it in, then make the following reason, right? Because Ka, so we can write our because as follows. Because Ka is approximately 0, because this is given as 8 times 10, right, the -4. So that's pretty much the same as saying 0, 1, 2, 3, maybe a 4, right? And then finally putting in your value, all right? So that's like a very small amount, right? Then putting your VO afterwards. So because of this, I mean, if you really subtract from 0.5 minus 0.0004, you approximately still have the same value of 0.5. So that means that 0.5 minus X is approximately the same as just saying 0.5. So not much has changed. So you have something like 0.499999, right? So you still have the 0.5. So essentially this can be rewritten as simply being X squared divided by 0.5, and we know the value here, it's 8 times 10 to the -4. Then what you now have to do is to solve for this particular equation, or solve for X in this scenario. Then you end up having your X squared being equal to 0.5 as that left and right hand side, multiplied by 8 times 10 to the -4. And of course, once you do this particular equation, once you do this particular side of the equation, you'll find then that you end up having an answer for X squared. And that answer is then going to be simply 4 times 10 to the -4. So 4 times 10 to the -4. Okay, then what do we then mean? We have got X squared is equals to 4 times 10 to the -4, which if you didn't make X as a result, you take the square root of the left hand side and the right hand side. So you've got this particular thing and you've got that particular thing, right? So I mean, technically it's plus minus, but in this case we choose plus because it's a concentration. We can't have a negative concentration. Therefore, we just have X is then equal to 0.02 mole per dm to the -3 cubic decimeter. Now the question is, we know what our value is for the X concentration, the dissociation concentration, right? But then what is the percentage that we have lost, or the percentage of dissociation? So percent dissociation is going to be given by what we have on the products, the dissociated percentages, divided by what we had initially. So that was then 0.5, right? Initially it was 0.50, right? And then we take that and multiply it by 100. And so the result becomes 0.02 divided by 0.05 times 100. Okay, let me remove that last 0 times 100. Okay, so we have this result. And when you do this percentage in your calculator, you'll find that the final result for the percent dissociation dissociation is simply going to be 4%. Right? And that is the correct value. That is the correct answer. And so this is how you would solve this question for acid reactions or acid dissociation.